Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for GRE. We have been solving GRE math problems out of this book here, the official guide to the revised GRE, the second edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 235. Please turn to it, page number 235, and today is our lesson number 332. This problem that you see there at the bottom of page number 332, or rather 235, that problem that you see there at the bottom of page 235 is the exact same problem that appeared on the exact same page number on the first edition of the revised GRE. We have already solved every single problem from this book. If you're interested in watching the original solution, which is done at a much slower pace, where I explain a lot of things in great deal of details, if you need that kind of help, you can go and watch day number 118 and 119. Here, we're not going to go into too much details. We're just going to do it. We're just going to do the problem, and I'm going to assume that a lot of the concepts that we're going to cover, that you're familiar with those concepts, and that you don't need any extra help. But like I said, if you need extra help, if you need to go at a slower pace, make sure you watch day 118 and 119, particularly day 118, where we talked about the concept of slope. What exactly is a slope? Intuitively, that is. So here we have a situation where we are asked to find the equation of a line going through 2 points. Point Q, which we are told is -2 and -3, and point R, which we are told is 4 and 1.5. But before we worry about finding the equation of the line, first we need to figure out the slope of the line. That's the very first step. That's the most basic ingredient. How do we find the slope of a line? Well, that's very straightforward. Slope equals the change in y over the change in x. And change in y, of course, is simply y2 minus y1 over x2 minus x1, which is the change in x. Here, our y2 is 1.5 minus a -3 over our x2, which is 4, minus a -2. Now, had we used the other way around, it would not have changed. We would have still gotten the same answer. We would have still gotten the same answer. Had we used this one as a y2, we simply would have had -3 minus a 1.5 over -2 minus a 4. And what will happen is that we'll end up with a negative and negative on top and the bottom, and the negatives are going to cancel out each other, and it's not going to change anything. You can use either of these points as a starting point. You can use either of these 2 points as a starting point, and the other one is the ending point, but we have to be consistent. If we're going to call this y2, if we're going to call this one y2, then this one of course has to be x2. We cannot mix them up. So anyway, this is going to give us 1.5 plus 3, which is 4.5, and here we're going to get 4 minus a -2 is going to give us 6. Multiply both sides, multiply the top and bottom by 10, so that we don't have to deal with the decimals, and that ends up with 45 over 60. Divide top and bottom by 15. If we divide top and bottom by 15, we end up with 3 over 4. There you go, that's our slope. Let's make a note of it here. Our slope equals positive 3/4. That's it, we're done with the slope. Now we can proceed to find the equation of the line, and we can go about doing that in several different ways. We're going to use the form of the equation, what is known as point slope form. So let's do it here. Let's use point slope form to find the equation of the line. The point slope form is so called because we're going to use one of the points. We have 2 points here. We have information. We have information on 2 points. Sometimes we only have 1 point. Sometimes we are only told that that line goes through this one particular point, and we are told the slope of the line. That's right. In that case, we use one point that is given to us, and the value of the slope, which we already know here. Let's use. Which point do you want to use? We have to make a decision. We have to use either point Q or point R as a point. Let's use Q. Using point Q, the point slope formula goes something like this: y minus y1 equals m times x minus x1. Y minus y1, we are using point Q, so that's negative 3, equals m, which is positive 3/4, over x times x minus x1, which is going to be negative 2. Now we have to simplify this form. We're going to do this on the top. Let's continue this on the top. So we end up with y. A negative and negative is going to become positive. So we have y plus a 3 equals 3/4 times x, and negative is going to again become plus x plus 2. Let's multiply both sides of the equation by 4. So that we can get rid of this 4. We are almost there. 4 times y is 4y, and 4 times 3 is 12. And here we have 3 times x, which is going to give us 3x, and 3 times 2, which is going to give us 6. We are still not quite done. We have to keep on going. We have to give this final answer in the standard form. A standard form of a line looks something like this. Y equals to mx plus b, where this is the slope. It has to be written in this form. In other words, we have to bring everything on this side. On the left hand side, only thing that we are allowed to have is y by itself. So let's get rid of 12. Subtract 12 from both sides. That drops out the 12. And 4y equals 3x. And positive 6 and a negative 12 is going to give us negative 6. We need the room. Now we have to get rid of this 4. Let's divide both sides by 4. And we're going to end up with y by itself, 3 over 4, x, which is our slope here, 3 over 4. You see right here, that's our slope, minus 6 over 4. And that's it, we're done. 6 over 4, of course, has to be written as 3 over 2, 3/2. But that's it, that's our equation. Our equation, written in standard form, is y equals 3/4 x let's do it here. Y equals 3/4 x minus 3/2. Now the last thing we have to do is what is known as, last thing that we have to do is what are known as the intercepts, the y-intercept and the x-intercept. X-intercept and the y-intercept are so called because those are the point where the line cuts the x-axis and the y-axis. So for example, if the line cuts here, this is the x-intercept. What's the value of the what is the value of the y coordinate here? Y is 0 because it's sitting on the x-axis. So x-intercept is so called because that's where the line cuts the x-axis. X-intercept is when y equals 0. And similarly here, if it goes through this point here, what is the x-coordinate of this point? The x-coordinate of that point is 0. That's where the line cuts the y-axis. This is called the y-intercept. Is when x equals 0. Finding the y-intercept actually is very easy when x equals 0. When x is equal to 0, 3/4 times 0 minus 3/2, this is just 0. So it's negative 3/2. So this part right here is our this part right here, y equals to 3/4 x plus a negative 3/2. This negative 3/2 is our x-intercept. Sorry, that's when x is equal to 0. This is our y-intercept. Don't memorize it. Like I just made a mistake here. That's because I don't memorize these things. Just don't memorize it. Just take a second to see if it makes sense. Inadvertently, I ended up calling it x-intercept, but then I realized that's where the x is 0. Where is x 0? X is not 0 here. X coordinate of this point is not 0 here. X coordinate of this point is equal to 0. That's the y-intercept. That's where it cuts the y-axis. This is the y-intercept, which is negative 3/2. Now we have to figure out this point here. X-intercept. That's when y is equal to 0. Let's do it here. Let's do it here. So our equation is y equals to 3/4 x minus 3/2. And y is equal to 0, remember. So what we have is 0 equals 3/4 x minus 3/2. Let's add 3/2 to both sides. In other words, bring the 3/2 to this side. So 3/4 x equals 3/2. Okay, I'm not going to show all the baby steps. I'm just going to tell you what's going on here. We're going to divide both sides of the equation by 3. If you divide this side by 3 and if you divide that side by 3, see this part here? 1 over 3 to this times 1 over 3. This 3 drops out. As I told you, I wasn't going to do it, so I'm not going to do it. I'm just going to rewrite it. So 3/4 x equals 3/2. If you divide both sides by 3, this 3 is going to drop out. And if you multiply both sides by 2, this 2 is going to drop out and 4 is going to become 2. So we have 1 over 2. So we have 1 over 2 x equals 1. And therefore x equals 2. Multiply both sides by 2, so that x equals 2. This is our x-intercept. X-intercept is where y is equal to 0. So we found our x-intercept is 2, which means the coordinate of this point are 2 and 0, and the y-intercept is negative 3/2. Negative 3/2 is going to have a very difficult time to be negative 3/2 up there. This is silly. I did not realize it, but our y-intercept comes out to be a negative number. It's down here somewhere. 0 and negative 3/2. That's it. So if you want to plot this line, the graph of this line is going to be something like this. There you go. That's the graph of the line, and that's all there is. And that's all we are doing there in the entire part there that they're talking about on 2.8.1. That's what they're doing there. They're just figuring out the slope first, then the intercept. The only thing that you're not going to see in the book is the graph of the line which is very easy. Once we know the intercept, we just have to put them in the graph there and just join the 2 points. I hope I did not make any mistake. Let me just quickly make sure that they have the same thing. They have x equal to 2 as the one of the intercept, and the other one is negative 1/2. Right there, negative 1/2. That's it. Seems okay. I will see you tomorrow. Okay? Bye now.